Hello, this is the R44 landing gear project presentation. My name is Peter Young. I'll be covering slides 3 to 8. So starting with slide 3. Here you can see helicopter parts on sale in the market. This is to point out that when designing for the private sector, your design must be able to sell. It has to have a significant improvement over existing designs. Our design team has paid special attention to this, as market factors have a lot of bearing on design considerations. Moving to slide 4. Our review of existing designs has shown that the R44 has the most market potential and a lot of room for improvement. The R44 is the most popular small helicopter in the world, meaning there are a lot of customers out there that might be looking for a potential upgrade to their landing gear. Unfortunately, it is also one of the most dangerous helicopters in the world, with 1.61 fatal accidents per 100,000 flight hours. Moving on to slide 5. So what to improve? The reason why this helicopter is dangerous has to do with the rotor and not the landing gear. But the landing gear can improve the safety of the aircraft. Namely, as a helicopter crashes, if the landing gear is able to absorb more kinetic energy from the crash, the deceleration of the pilot won't be as rapid, thus increasing the pilot's chances of survival. Currently, as you can see, the landing gear is made of aluminum tubes. What happens is the crossbar fails first, and it doesn't allow for the rest of the parts of the landing gear to absorb that kinetic energy. Moving on to slide 6. Here you can see a bit of a teaser of what was done with the design. The cross tube was completely redesigned. The R44 is based off of the R22, which was designed in 1972, which means that labor was cheaper. Computers weren't a thing, so the existing design relies heavily on a lot of different parts. It actually has 211 parts. So our goal was to save cost by reducing the number of parts that needed to be painstakingly installed, the labor costs. The savings in labor costs allows us the budget to design something more complex and with more expensive material if we need it. Therefore, the cost was maintained, weight was maintained in order to keep the same flight characteristics for the customer, and the design was made drop-in. More on that in the next slide, number 7. So, in order to be able to swap in our landing gear, it's important that the dimensions of our design match the existing design closely. Robinson doesn't provide detailed dimensions of its components. It does, however, have external dimensions shown on the image on the left. It also has an illustrated parts catalog, which helps the user order parts for the helicopter. Together, these resources were used to create an accurate computer-assisted design model. So, the parts in the catalog were assembled in MS Paint, resulting in a blueprint from an isometric perspective, and then iterative scaling was used to make the 3D design fit the blueprint. So on the right you can see an example of the blueprint overlaid on top of the 3D CAD model. So in the rest of the presentation, my colleagues will discuss how the stress analysis and material selection was performed